Emergency stop regulations are not found within the National Electrical Code. Instead, these crucial safety requirements are usually detailed in local building codes and specific safety regulations. It is important to understand that the National Electrical Code, while comprehensive in its coverage of electrical installations, focuses primarily on preventing electrical hazards such as fire and shock. Emergency stop systems, however, are designed to mitigate a broader range of risks, often involving mechanical or process-related dangers. Local building codes are established and enforced by municipal or regional authorities. These codes address a wide array of safety concerns within buildings and structures, including fire safety, structural integrity, and accessibility. Emergency stop requirements within building codes typically outline the circumstances under which emergency stop devices are necessary, their required locations, and their performance criteria. For example, a building code might mandate emergency stop buttons in areas with heavy machinery, conveyor systems, or hazardous materials. These buttons must be easily accessible and clearly labeled, enabling personnel to quickly halt operations in the event of an emergency. Safety regulations, on the other hand, are often promulgated by governmental agencies responsible for workplace safety, such as the Occupational Safety and Health Administration, or OSHA. These regulations aim to protect employees from hazards in the workplace. Emergency stop provisions and safety regulations often specify the design, installation, and maintenance of emergency stop systems to ensure their reliability and effectiveness. For instance, OSHA regulations might require that emergency stop devices be regularly inspected and tested to verify their proper functioning. They may also dictate the color, size, and placement of emergency stop buttons to maximize visibility and ease of use. When designing or installing an emergency stop system, it is crucial to consult both the local building codes and the applicable safety regulations. These resources provide the specific requirements that must be met to ensure the safety of personnel and the protection of property. Ignoring or neglecting these regulations can result in serious consequences, including fines, legal liabilities, and, most importantly, injuries or fatalities. To effectively navigate the regulatory landscape surrounding emergency stop systems, firstly, identify the relevant local building codes for the specific location where the system will be installed. This may involve contacting the local building department or consulting online resources. Secondly, determine the applicable safety regulations based on the type of industry or workplace. This could involve researching OSHA standards or consulting with a safety professional. Thirdly, carefully review the requirements outlined in the building codes and safety regulations, paying close attention to the specific details regarding the design, installation, and maintenance of emergency stop systems. Fourthly, ensure that the emergency stop system complies with all applicable requirements. This may involve selecting appropriate components, designing the system layout, and conducting thorough testing. Fifthly, document all aspects of the emergency stop system, including its design, installation, testing, and maintenance. This documentation will be essential for demonstrating compliance with regulatory requirements. Emergency stop systems are critical safety components in many industrial and commercial settings. Their purpose is to provide a means of quickly and reliably halting operations in the event of an emergency, thereby minimizing the risk of injury or damage. These systems typically consist of one or more emergency stop devices, such as push buttons or pull cords, connected to a control circuit that interrupts the power supply to the equipment or machinery being controlled. When an emergency stop device is activated, the control circuit immediately energizes the equipment, bringing it to a safe stop. The design and implementation of emergency stop systems must adhere to strict safety standards and regulations to ensure their effectiveness and reliability. These standards and regulations address various aspects of the system, including the type of emergency stop devices used, their placement and accessibility, the wiring and control circuitry, and the system's response time. One of the key considerations in the design of an emergency stop system is the selection of appropriate emergency stop devices. These devices must be robust, reliable, and easy to use even in stressful situations. Push buttons are the most common type of emergency stop device, but other options include pull cords, foot switches, and wireless remote controls. The choice of device depends on the specific application and the needs of the users. The placement of emergency stop devices is also critical. They should be located in easily accessible locations where personnel can quickly reach them in the event of an emergency. Typically, emergency stop buttons are placed near workstations, control panels, and other areas where hazards are likely to occur. They should also be clearly labeled and visible, even in low light conditions. The wiring and control circuitry of an emergency stop system must be designed to ensure reliable operation. The wiring should be properly sized and protected from damage, and the control circuitry should be designed to prevent false tripping. It is also important to incorporate redundancy into the system to ensure that it will function even if one component fails. The response time of an emergency stop system is the time it takes for the equipment to come to a complete stop after an emergency stop device is activated. This response time should be as short as possible to minimize the risk of injury or damage. The maximum allowable response time is typically specified in safety standards and regulations. In addition to the design and installation of emergency stop systems, regular testing and maintenance are essential to ensure their continued effectiveness. Emergency stop devices should be tested periodically to verify that they are functioning properly. The wiring and control circuitry should also be inspected for damage or wear. Any problems should be addressed promptly to prevent system failures. Emergency stop systems are not a substitute for other safety measures, such as machine guarding and lockout/tagout procedures. However, they provide an important layer of protection in the event of an emergency. By following safety standards and regulations and implementing a well-designed and maintained emergency stop system, businesses can significantly reduce the risk of workplace injuries and fatalities. Emergency stop systems are used in a wide variety of industries, including manufacturing, construction, mining, and transportation. They are also used in commercial settings, such as hospitals, schools, and office buildings. In manufacturing, emergency stop systems are used to stop machinery such as presses, lathes, and robots. In construction, they are used to stop cranes, hoists, and other heavy equipment. In mining, they are used to stop conveyors, crushers, and other mining equipment. In transportation, they are used to stop trains, buses, and other vehicles. In hospitals, emergency stop systems are used to stop medical equipment such as X-ray machines and MRI scanners. In schools, they are used to stop laboratory equipment and other potentially hazardous equipment. In office buildings, they are used to stop elevators and escalators. The specific requirements for emergency stop systems vary depending on the application and the applicable safety standards and regulations. However, the basic principles of design, installation, testing, and maintenance remain the same. To ensure the safety of personnel and the protection of property, it is essential to consult with qualified professionals when designing and implementing emergency stop systems. These professionals can provide guidance on selecting appropriate components, designing the system layout, and conducting thorough testing. They can also help to ensure that the system complies with all applicable safety standards and regulations. The National Electrical Code covers a broad range of electrical safety topics, but it does not specifically address emergency stop regulations. The National Electrical Code is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is developed and published by the National Fire Protection Association or NFPA and is widely adopted by state and local jurisdictions throughout the United States. The National Electrical Code covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect changes in technology and industry best practices. The National Electrical Code is an important resource for electrical contractors, engineers, and inspectors. However, it is not a substitute for professional judgment and experience. It is essential to consult with qualified professionals when designing and installing electrical systems. The National Electrical Code is organized into chapters, articles, and sections. Each chapter covers a specific topic, such as wiring methods or overcurrent protection. Each article covers a more specific aspect of the topic, such as the installation of specific types of wiring or the selection of overcurrent protection devices. Each section provides detailed requirements for the specific aspect of the topic. The National Electrical Code also includes tables and examples to help users understand and apply the requirements. These tables and examples are based on industry best practices and are intended to provide guidance on how to comply with the code. The National Electrical Code is constantly evolving to reflect changes in technology and industry best practices. The NFPA updates the code every 3 years to ensure that it remains relevant and effective. The updates are based on input from a wide range of stakeholders, including electrical contractors, engineers, inspectors, and manufacturers. The National Electrical Code is an important resource for anyone involved in the design, installation, or inspection of electrical systems. It provides a comprehensive set of standards for the safe installation of electrical wiring and equipment. By following the National Electrical Code, electrical professionals can help to ensure the safety of people and property. Emergency stop regulations are critical for ensuring workplace safety. They provide a means of quickly and reliably halting operations in the event of an emergency, thereby minimizing the risk of injury or damage. While the National Electrical Code does not specifically address emergency stop regulations, it is important to consult local building codes and safety regulations to ensure that emergency stop systems are properly designed, installed, and maintained. The absence of specific emergency stop regulations in the National Electrical Code does not diminish the importance of these systems. Rather, it reflects the fact that emergency stop systems are often tailored to the specific hazards and risks associated with a particular workplace or industry. Local building codes and safety regulations are better suited to address these specific needs. Building codes, as previously mentioned, are established and enforced by local jurisdictions. They address a wide range of safety concerns within buildings and structures, including fire safety, structural integrity, and accessibility. Emergency stop requirements within building codes typically outline the circumstances under which emergency stop devices are necessary, their required locations, and their performance criteria. Safety regulations, often promulgated by governmental agencies like OSHA, aim to protect employees from hazards in the workplace. Emergency stop provisions and safety regulations often specify the design, installation, and maintenance of emergency stop systems to ensure their reliability and effectiveness. These regulations may also dictate the color, size, and placement of emergency stop buttons to maximize visibility and ease of use. In addition to building codes and safety regulations, industry-specific standards may also provide guidance on emergency stop systems. These standards are developed by organizations such as the American National Standards Institute or ANSI and the International Electrotechnical Commission or IEC. Industry-specific standards may address the specific hazards and risks associated with a particular industry and provide recommendations for emergency stop systems that are appropriate for those hazards and risks. When designing and implementing emergency stop systems, it is important to consult all applicable building codes, safety regulations, and industry-specific standards. By following these guidelines, businesses can help to ensure the safety of their employees and the protection of their property. Emergency stop systems are an essential component of a comprehensive safety program. They provide a critical means of quickly and reliably halting operations in the event of an emergency. By understanding the applicable regulations and standards and implementing a well-designed and maintained emergency stop system, businesses can significantly reduce the risk of workplace injuries and fatalities. Remember that the information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals when designing and implementing emergency stop systems.